Okay, here's another tutorial for using the trial version of the SolidCAM. And in this video, I'm going to show you how to do the work for something similar to the part number 2 in the assignment of the CAD CAM. So once again, we start with SolidCAM part, and I'm going to set a new milling operation. The thing will upload as normal. Choose as external. Say OK. uh, check the previous video on how to do the setting for the trial version of the SolidCAM. Okay, now once again we are going to choose the stock material. This time I will try to get the material to be a little bit larger than this shape, so we can give some chance for the roughing operation to make the circular shape. So I will add here 4 millimeters instead of 2 in each direction, just to increase the chance of having a better shape while I'm going to do the cutting. Okay, I will leave. Well, usually we leave the thing at the back to have 6 millimeter to protect the table. However, I'm going to leave the Z positive and Z negative to 2. I don't want to have too much material at the top and the bottom, but instead of that, I just want to have the extra material on the side, so I will have the best circle cutting later. Okay, so we choose the stock material. Now again, to define the stock coordination system, again I'm going to choose the select surface, and I'm going to choose the highest surface of the part. Now the dead-on point has been identified successfully. Now I will accept everything else and move to uh, the machining process. Okay. Okay. Now we are at SolidCAM. Now, before I get to choose the tools, I need to check what are the diameters we have. So we have here a diameter of 12 millimeter. You can read that here at the bottom, 12 millimeter. And I have 5 millimeters. And I have the large one, which is going to be about 60 millimeter. Now, just remember something, it's almost impossible to have a cutting tool doing the drilling operation, which is going to have the diameter of 60 millimeter. It's obviously we can have one with the multiple cutting heads that can do the face milling only, and again to show that in the list. So just remember once again, we have a 12 and we have 5, but we need a cutting tool at larger diameter to remove the material on these surfaces at higher rate. And for example, I'm going to use the classical 20 millimeter diameter cutting tool. So we go to the cutting tool, right click, part tool we're going to choose. The first cutting tool. Now, actually, that's the one I tell you about, the face milling, which can have a larger diameter. But for this one, the maximum diameter I saw was something about 1 inch, which can do the work easy. So I'm going to go with the end milling, and I'm going to choose the diameter to be 20 millimeter, 20 millimeter. And I think that the height here is good to be the CL here is 24, which is quite good. Actually, it can work. But anyway, I'll try to find a cutting tool which is going to have more depth for the SL, so it can do the pocketing for the hole we have in the middle, which is going to have the height of 40 millimeters. So the cutting side, I will take this one to 40, and everything else will be changed accordingly. 40. The shoulder length SL is 30, so this one should go up to 50. It should be longer. Okay, and the outside holder length is going to be 80, and the total is going to be 100. Okay, now this came from experience, but you can find something which is going to have 20 millimeter and have the total length to be 100 millimeter. Now the number of the flutes or the number of the teeth we're going to have here, this one is 2. I can make them to be 4. It's very normal to have 4 flutes in the end, and this will increase the rate of the rate of the material removal, because usually we calculate per teeth in the case of the milling operation. Now this was the first cutting tool. I'm going to save that. Second cutting tool is going to be the 12 millimeter diameter. I'm going to use this one for drilling only, so I will choose this one as 12 millimeter, and the maximum depth from here to here is going to be 30. So I have to be sure that the cutting length is going to be 30. This one is 24, so it's not going to do the job, and I have to change this parameter to make this one to uh, 32, and this one is going to go up to 40, and the rest is going to remain the same. So 40, 32. So 32 will be able to drill this hole, which have a depth of 30 millimeter. This will be the second cutting tool. Third cutting tool should have the diameter of 5, okay, 5 millimeter, or half centimeter, 5 millimeters. And the depth here is going to be 20, and this make the 24 is going to be acceptable as the working length. The flutes are going to leave for these two to be 2, because we just do the drilling operation, and usually the drilling tool is going to have the 2 flutes or the 2 teeth for the drilling operation. Now I'm going to say this cutting tool as cutting tool number 3 and go out. Now going for the operations, I'm going to add the milling operation. The operation I'm going to do first is going to remove the material of this to this height for the whole diameter for the larger one. So I will take everything outside this circle, the outer one, to lower by 10 millimeter depth. So I'm going to add the milling operation. I'm going to use the 3D HSR, or 3D higher speed roughing operation. So I will choose the geometry, and this will be the part in general. Okay, and then I'm going to choose the tool. It's coming. Okay, I'm going to choose the tool, and I'm going to use the tool that can remove the material at higher rate, and this will be tool number 1, which have the 20 millimeter diameter. Say OK. Now we go to the other operation. I'm going to define what are the boundary I would like to cut in the first process. So I'm going to create that manually. You can see that we have multiple options, and what I'm going to do is I'm going to make the defined boundary, user defined boundary. I don't want to choose a face now. Okay, so I will go now to define the boundary, and I'm going to click anything outside this circle. This will be the chain number 1, and within this circle. So if I'm going to take a look from the top, it's going to be between these 2 lines to this level. So I'm going to check the level uh, in the next step. Okay, so we don't have anything about the level here. So let's go to the number of the passes. We have here something about the level. So I'm going to define that by target. The top level is going to be this one, which is 0. And the bottom level is going to be this one, which is -10. Okay. For the other parameters, we have the step down, or how many millimeter we're going to remove in every pass. So 1 is going to be too low. For 10, I'm going to make it to be 3. So it's going to have 3 passes as rough cutting, and 1 pass as the finish cutting. I will make this one to be as a constant and a flat. So 3, 3, 3, then 1 to make it a flat surface. Percentage of the initial 2 diameter is going to be the offset. Here is 50%. I will leave it as 50%. I will leave this one as it is, which is the spiral cutting for the operation. I think that we have more opportunities about the step down. The last level to even is going to be one, I think, 3331. Edit passes are not going to work with this one, and we're going to leave and check what will be the operation shape as we're going to have it. So it's doing the calculation now, and it's going to sketch the shape for us. Okay, now that's what we got. That's what we got. Now let's take a look from the side. Okay, now I still don't understand why I have this line out. However, let's check. Yeah, we have three levels. Uh, one, two, three. Oh, sorry. I think this is more than. Yeah, the last one was one here. Yeah, 3 millimeter, 3 millimeters, 3 millimeters, and one. Let's make it 10 millimeters in total. Okay, so this was the first operation. Now the second operation will be uh, simply the same. So again, to add a new milling operation, 3D HSR, repeat the same process. Again, to choose the body to be this one, geometry. Okay, CAD model. Okay, uh, the same cutting tool, tool number one. Yep, and we are going to have the uh, boundaries. Now the boundary is going to be different. And now it's going to be anything between here as the first chain. Okay, and this one is going to be the external chain. Okay, so I'm going to remove the material between this line and that line to the new level is going to be less than this one by 20 millimeters, I think. So we say okay, and we go to the next step, which is going to be the passes. Now for the passes, again, I think. Oh, first let's check, identify the top. So this will be the top surface. Is -10, and the bottom one is going to be that, which is -30, I think, or -25. So this height is 15 millimeter. Say okay. Okay, and that's when you have 15. I will take this tab down by. If I get to take it by 4, we're going to have it 12, then 3. No, so I'm going to take it by 3.5 and 3.5, and this will make it 4 passes. Constant and flat, and I get to choose the step down. The last level to even is going to be 1, and this will make it 15 passes. Save and exit, and this will be the calculation for the tool path. Will look like the shape. Just give me 1 second. Okay, now we have the cut till the end. Now I think that this small diameter, which is I don't figure out why it's happened, is going to cause a problem if I going to do the simulation for the rest of the material. Let's take a look. Well, no, it's good. Yeah. Yep. So it's cut at the two levels, as you can see here, the 10 millimeter and the 15 millimeter. We're going to remove the rest of this material later by doing the profile cutting to create a circle. Okay, now what we need to do is we need to make this big cylindrical hole, or I'm going to call it pocket, by using the same cutting tool to remove the material at higher rate. So again, to do the setup and add the milling operation, I'm going to choose this operation as a pocket. Now, in the pocket, what we need to define first is going to be the outlines, or the what we call the chain. So the chain is going to be this one. So I'm going to click on the circle here, say OK, and say OK. Now again, the cutting tool will remain the same because I would like to remove the material at a higher rate. So it's going to be the same value. Click OK. And the levels identify to be 40 millimeters. So the upper level is going to be starting from the top here and ending at the bottom down there for 40 millimeter. Every step is going to be 10 millimeter until we're going to reach that. Okay, technology is going to leave it as a counter, and the percentage of the offset or the overlap is going to be 50% of the diameter of the cutting tool. I'll accept this one. What do we have else? Nothing. Nothing. Actually, yeah, just start from the inside and going to the outside. We can start from the outside and coming to the inside. It's up to you. I will choose this one. So the drilling will be from the side, then it's going to go another step and finishing at the end. And this one, as I said, is going to start drilling in the middle, then start to enlarge the diameter. And say save and exit. This will be the operation of the counter. If I'm going to calculate that, as you can see here, is going to start drilling here, make a full circle, then moving to the outer circle and make a full rotation, remove the material from inside to the outside. We can make it from the outside to the inside, so it's going to start to do this full circle first, then go into the inside to make the smaller one, and so on. Now, what we need to do is the drilling operation. So the first drilling operation is going to be done by using the 12 millimeter diameter cutting tool. And then the small one is going to be done by the 5 millimeter diameter cutting tool. So I'm going to add the drilling operation, drilling, and I'm going to choose these 5 holes. So coordination system. I'm going to choose, oh, sorry, not coordination system. We're talking about, oh, yeah, it's telling me about the geometry drilling. Yeah, I'm going to select the circles here. So I'm going to make them in sequence: 1, 2, 3, 4, and 5. Okay, so this will be the sequence of the drilling. I didn't form the bottom because this will simply going to define what will be the depth of the cutting of the drilling. Okay, now the cutting tool, of course, is going to be 12 millimeter diameter one. Double check that, half inches. Yes. Okay, go to the next step. The levels is going to be defined automatically. It's going to be from 0 to 40. From 0 to 40. Now I leave it from 0 to 40, so any trouble is not going to be hitting with this tower. And technology, of course, is going to be drilling, so no need to define that. And I'm going to save and exit, and this will be the simulation process for it. You can see that this will be the movement 1, 2, 3, 4, and 5 before it's going to leave to the origin point. Now the other drilling is going to be for the multiple small holes for the cooling of the disk. And let's try to find out if we can select all the holes in one selection. So again, to add the drilling operation again. Okay, and again to try to use select all the circles by I don't know if you can do that, but let's give it a try. Selected, no longer can be very selected. Show the center points. No. Um, what's happening if I get to try to select it like that? Yep. So I selected all the holes together, and I'm going to remove the large holes because we already drilled that. So the first one is that you can see it's numbered as one. I'm going to delete this one. Delete. Click on it and press delete. 10 delete yet. Did I delete one of them? Which one I deleted? Oh, I deleted the wrong one. So again, I'm going to delete everything and try to select them in another proper way. So select shift and select all. Can we do that? I think it should be done, but it's taking its time. Yeah, I think now it's all selected. If I again press delete. Oh, yeah. Oh, just click by mistake. It's taking time. So select the first one, shift, and select the last one, and just wait for a while. And yeah, now you press delete in your computer. Say yes to all. Okay, and now let's try to choose all these holes and avoid the large one. So I think I'm going to do it this way. I'm going to select. Uh, oh no, I should get it closer. Okay, so I will get it closer. I'm going to select 3 rows each time. One, does it? Oh, maybe I need to select the whole body then. Okay, so let's try it. Let's try this one once again. Click for the whole thing. Going to analyze the holes, and I will try to remove that, which are the 41, the 70, 66, 67, 68, 69, and 70. So I will go to the end, and I will try to 70 to 66 first. And okay, I'm going to click shift and okay, so I'm going to delete these holes. I don't need them because it's already been drilled earlier. Uh, didn't do it yet. Uh, again, let's do it one by one. So this will be the first one. Delete. Yes. Yep. Now we have 66 here. Delete. Yes. The 66 again. Delete. Yes. Delete and delete. Okay. Now this will make it much easier to select all the holes together. Now this is number 65. The one I want to lead now is going to be 41. So I will go up and try to find the hole number 41 and delete it. And this will make the selection I have. It's only for the 5 millimeter diameter holes. Yep. So that's the whole sequence, and it will start as 1, 2, 3, 4. Ah, that's strange. 5, 6, 7, 8, then continue doing all the drilling operation. I'll accept that as my selection. Going to the tool, I will choose the 5 millimeter, which is the tool number 3. Okay, and the levels now is going to start from 0 to, well, it doesn't have to start from 0 here. So I'll try to do it to start from here and all the way down to drill depth to that level, minus 40, and of course going to be the same as 30 millimeter. Okay, now we have that technology is going to be drilling, save and we are going to do the calculation for the line of this one. Okay, now it's done. I'm going to do the calculation for that, and this will be the movement of the drilling operation for these spots. Now, if I get to do the simulation of this one individually, I'll try to make it to the fastest speed, make it in 3 dimensions, and play. Boom, it's gone. Okay, so I'll try to do the simulation for all the operations. Okay, and I will do the file, simulate, um, 3D simulation, and I just want to check something later. So this will be the operation we are going to have. First, cutting the first level. It's going to be do it in 3 steps. Now we start with the second level soon. Okay, so it's done all the operations. Now for the part that you're not going to make a video for, I would like to have this photo. I would like to have this photo. And of course, you need to explain the steps of the setting for this one. Okay, now we still have to do one more operation, which is going to be done with the setup number 2. When I'm going to fix the part on the table using these holes, remove the vise from the side, I'm going to do the profile cutting around that to get the circular shape. Because if you're going to see this one, you will see that the rest of the material will look like that. Well, it's not showing that, but it should be the part but with the square shape around. I just want to check about these options. I forgot about them. Okay, so the machine simulation, this one is not going to be defined because we don't have the machine here. So I'll verify. Now you can see that yes. Okay, so this will show you how the material is going to be removed to have the final shape. Okay, now crash stock with the rapid move G0 change in the step single. Yes, I'm going to accept that anyway. We should change this one manually to take it to a higher level. Okay, so again to show you how to do that before you're going to process it to the machine. Because usually for such a similar part, it should consider that the stock is going to be circular, not square shape. So one of the solution we can do with this one is drill the holes here at the beginning of any operation, hold the part using the screw, do the profile cutting first, then you come later to do the cuts for the extra work. That's annoying. Actually, this was the main reason that we got the shape of the rest of the material was not completely showing because principally that we have okay, now it was doing the thing. Okay, now we done. Okay, because principally that it was hitting the part every time, try to go to G00, and this was one of the main problem. Anyway, as I told you, we can set that later by getting the G00 to go to higher level, then moving to the end. Okay, now, oh yeah, because remember, we had 2 extra millimeter from the other side, and that's why it didn't went all the way down in this side. Okay, now I'm going to do the profile cutting. So again, to add another operation here, again to add, and again to do the profile cutting, and again to select, of course, the 20 millimeter diameter is going to be the tool. Click on new, and my cutting now it should be on the chain, and I'm going to use the chain and the lower surface here. Okay, just that. And say OK. The cutting tool is going to be 20 millimeter diameter, large one, because once again it's going to remove the material at a higher rate. The levels is showing 0 to 40. I don't need, oh yeah, I'm going to leave it by 0 because you remember we still have this high material on the side, so I'm going to accept that. And I will leave this one at the beginning as the left, and I'm going to change it later when I'm going to see the thing. Depth is going to be constant, and I think that the step equal is going to be by 10, is already mentioned here. For the finish number or the pass is going to be just 1, and the external corner strategy is going to be rounded. Save and exit. And first I'm going to do the calculation. I will see that, yes, so this will be the cutting tool is going to work on this tool path, starting from here, going to this tool path and do the cutting. If I'm going to do it right, this will go inside the work part instead of the outside of the work part. I'm going to simulate this one, and let's check what will be the rest of the material we're going to have here. It should be cutting a circle. Yep. So let's cut a circle. Don't worry about that. That's just because it's considered that you remember from the top we have extra 2 millimeters, and that's why we have this edge. But actually, this is not going to be presented. So it's going to cut around and finishing the rounded shape, and the what's that? Not the rest of the material. So verify, and the operation will simply going to be continue. Oh, yeah. There's a clash between the arbor of the machine and the stock is was detected. That's mean I'm going to need to have a longer cutting tool. Okay, now when we say that the arbor, you can see that here we have a contact. This shouldn't be happen. So I need to change that. Maybe I can do that now. If I'm going to go and select that uh, the cutting tool, the part tool table, and I'm going to modify this cutting tool now before we're going to move. So we said that this one was 40, is going to be at least 42. So I increase this one to 42. Okay, and I'm going to save it and exit. And I think now is going to work probably. Okay, so yep. Okay, so I'm going to check that on the solid verified. Yeah, now it's done the job. Okay, again, done. Okay, and we had the part ready. Now just remember that this level has been lefted because simply we have the extra 2 millimeter at the end, If we're going to put a protection layer like a piece of wood, we don't need to have this extra 2 millimeters. Okay, so that's the only thing. For the other part, we have a real CAD model. We should have a facing for the other side. So you just need to complete the same process on the other side. Okay, so thank you very much. And if you have any question, once again, you can come back.